f is defined on the interval -4 to 3. The graph of the 2 quarter circles and 1 line segment, as shown below, let g of x equals 2x plus the integral of 0 to x f of t dt. That's your graph. I'm not going to resolve this. Part A. Find g of -3. Find g prime of x and evaluate g prime of -3. Thank you. First, we plug in order to find g of -3, you plug in -3 into your x's.
He's just too excited.
Plugged in -3. I don't know if you can see that, but plugged in -3. Next step. Solve. You have to switch this integral into a negative in order to switch to 0 and -3, because you always start from the lowest and go to the highest. Look at your graph, which I erased, and will not draw again. And as you can see, from -3 to 0. Andrew is wrong. Andrew wrong. You have this semicircle right here that we have to figure out the area of. The area of a circle is pi r squared. But since this is only a quarter of a circle, we divide it by 4. So this is equal to pi r squared divided by 4. Plus a radius would be 3. Variant theta for r. And now you solve this. The answer for g of 3 is equal to -6 minus 9 pi divided by 4. That's your answer for g of -3. Now we have to find g prime of x and g prime of -3. Why did you erase the goddamn graph? Start off with what we're given. 2x plus integral of 0 to x f of t dt. We have to find the derivative of this. Derivative of 2x is 2. The derivative of the integral from 0 to x f of t is just f of t. Because the integral and derivative cancel each other out. Now, plug in -3. Yeah, we plug in -3. So g prime of -3 equals 2 plus f of -3. We look at our graph, which I erased again, which I will not show, I will not draw again, I'm lazy. But if you look at the graph, f of -3 is 0. So this is equal to 2 plus 0. What is 2 plus 0? 2. G prime of -3 is equal to 2. Settle down. Part B. Determine the x-coordinate of the point at which y has an absolute maximum on the interval -4 to 3. Justify your answer. I wrote this way too big, so I'm going to erase it. So I have space for the problem. First, you must figure out what g prime of x equals. Or what makes g prime of x 0. Okay, what g prime of x equals, which is 0. No, we had to make g prime of x equal 0. Just like numbers. So what value of f of t would make 2, right, what value of f of t will make g prime of x equal 0? That's right. -2.
He's just too excited.
0. Okay, you see that? That's a shit. Okay. Now we'll use. Now we will find the slope of the line segment that was given in the graph. In order to do that, we use 2 points in this line segment, which was 0, 3, and 3, -3. Is that even on the screen? Okay. So 0, 3, 3, -3. You live within x1, y1, x2, y2. Now you put a y1 minus y2 over x2, x1 minus x2. You end up with 6 over negative 3, which simplified equals negative 2. Negative 2, negative 2. Thank you. Now you use the formula y minus y1 equals n x minus x1 to find an equation for the line segment. Plug in your y1, y minus 3 equals m is the slope. That's the slope from negative 2 x minus 0. Simple algebra right here. You end up with y minus 3 equals negative 2x. Add 3 plus 3. Y equals negative 2x plus 3. You make y into 2 in order to make this g prime of x 0. 2 equals negative 2x plus 3. Just write up here. Two equals negative 2x plus 3. Simple algebra. Subtract 3 from both sides. You get negative 5 equals negative 2x. Divide by negative 2 on both sides. And an x value on which there is a maximum is 5 over 2. So at the x coordinate 5 over 2, there is an absolute maximum for g of x. Now how do I justify that answer? Justify it by writing a sentence sort of like this. There is an absolute maximum at x equals 5 over 2 because g prime of x is greater than 0 for the interval of negative 4 through negative 4 to 5 over 2, and g of x is less than 0 for the interval of 5 over 2 to 3. That's how you justify your answer for part B.